Welcome to our dissection of the kidney. What I want you to note is that we are working today with a pig kidney. The pig kidney is about twice the size of the human kidney. If you consider the size of your fist, this is about the size of the human kidney versus the pig kidney. So we can see here that the pig kidney is about double my fist. There's also quite a bit of fatty tissue that surrounds the kidney that the lab supply company has conveniently cut away for us today. We might see some remnants of that when we're viewing this, but very little remnant of the fatty tissue that was here. Why that's so important is you may remember from early on in your study in A&P 1 of the body cavities is we have a peritoneum which surrounds most of the abdominal organs. With the kidney is actually behind that membrane. So the kidney doesn't get the protection of the peritoneum that other abdominal organs get. That said, we have a little, what I like to refer to as the bubble wrap of the kidney, which is the fat that surrounds the organ.
Thank goodness for that.
Exactly. So here, folks, we're looking at the incoming and outgoing structures of the kidney. So in this section, we're going to be able to first identify the easiest to sort of recognize structures. So this one right here, you're going to see it has a nice round lumen, nice and open. This is where blood comes into the kidney. Were we to have a better probe here that was a little bit easier to maneuver, we'd be able to follow this into the interior, and that's where blood makes its pathway in for the filtration process. You can recognize this because the artery actually, unlike veins, an artery has a much thicker musculature. It has a lot more elasticity to it than what we see with the veins. And this is why it holds its shape even when it doesn't have fluid in it. So that's what we're looking at there. When we notice the vein in a moment, we're going to see that once there's no fluid in the veins, once there's no blood in that vein, it tends to collapse and go very flattened. And that's how you can tell the difference between the artery and the vein. Before I move to the vein, I'm actually going to take us to this structure, which is also very easy to recognize. This one's very easy for me to maneuver my probe. And what you see is this is our ureter. So this is one of the outbound vessels for the kidney. This is where, once the blood has been filtered, anything that we're no longer intending to reuse in the body is going to make its exit here. And that's going to make its exit out into, we go from here, the opening, this is the ureter, all the way down to the opening that connects with the urinary bladder, where we're going to hold the urine until it's time to do an excretion. So this is sort of the final stop on the train for those wastes that we no longer have a use for. Anything else that we've filtered in the process of doing this filtration at the glomerular level, which we'll get into in a moment, is anything that we have deemed worthy of reuptake and reuse is going to make its way out of the kidneys through the veins. So we're going to try to locate the vein now as we move forward. You're going to find the vein is much harder to locate because it does indeed collapse when there is no blood present. And so this is what we're seeing right here. You see this opening where my probe is, but we didn't recognize that as easily because, again, the strong musculature of the artery is what kept that nice and open for us. Here, the vein has collapsed a little bit, but it is still findable. And if we were to have fluid here, this would reform and make a nice round lumen for us once again. So this is the hilum, and these are the three structures, two that are outbound, the ureter and the renal vein, and one that is inbound, the renal artery. Next, we're going to take you through a journey of the interior of the kidney.
Perfect. Do you want to dissect?
I think we should dissect.
Let's dissect.
Okay. So you're going to see, if you're still watching, and we haven't cut this part, you're going to notice, friends, that as we make this dissection, it's rather difficult because, again, this capsule is indeed really very strong to protect the interior of the kidney and where we have all of our functional units. Now, try to make sure that you're always keeping your fingers away from the blade. I'm making some superficial cuts here, and we're doing a frontal section, so we're going to have an anterior and a posterior section of this kidney. This is much harder than it looks, folks. And if you don't have to try this at home, don't do it.
But if you do have to try it at home, be very careful. Never
Please.
cut toward your fingers. Always cut away from yourself.
Yep, always away. It's not as easy as it looks, folks.
I don't think you're making it look easy.
Don't
It
you
is
feel
as easy as it looks, which is not easy at all.
Now that we are in the interior of the kidney, let's get our bearings. So there's 3 separate divisions that we want to pay attention to when we're thinking about the kidney. So in the interior here, we have our outermost cortex. The outermost cortex of the kidney is kind of shaped like a C on these sides, so you can see it kind of makes its way around. This is the functional, really one of the main functional areas of the kidney. You're going to see that we have lots of dye here in the cortex, and that represents those blood vessels. Specifically, we're seeing a lot of venous activity, so this is going to drain the kidney. We don't see the red as well here, but we do maybe on this particular side. We see a little bit more of the red, and that's going to be the arterial blood that's making its way in for filtration. And then it makes its way back out, and then through the larger vessels, and then out through the renal vein, which we had looked at. So the thing that I want you to note about the cortex is again where most of the action, most of the really exciting and important action is happening. We have what are called nephrons here. Nephrons are the functional unit of the kidney, and they are the structures that are responsible for doing this big work of filtration. Nephrons that live here in the cortex are called cortical nephrons. We do have other nephrons though, which is going to transition us to looking at the next section of the kidney called the medulla. The medullary portion of the kidney does have some cortical nephrons that are going to jut down into their surface here, and those are going to be called juxtamedullary nephrons. The other thing that I want you to notice when you're looking at medullary tissue is they're striking because you can see here that we have pyramids. These are called the renal pyramids. The renal pyramids, depending on what specimen we look at, there's going to be a different number. So not all of us have the same number of pyramids. But what's unique here is between those pyramids, they're differentiated by what are called renal columns. The end of the pyramids is the renal papillae, which, if this were intact and together, would drain into the minor calyx, which is then going to couple with its friend next door and drain into a major calyx, which drains to the renal pelvis, which drains to the ureter. And that, my friends, is our dissection of the kidney.
Beautifully done, Mel.
Stay tuned for the physiology of the kidney in our next video.